Our logical statements share a problem with arithmetic statements. Sometimes you can't tell what's meant just by looking at an expression. In my example here, for example, does this mean this, where the conditional has to be done first, or this, where the conjunction is done first? Well, you can check on your own by writing out the truth tables that these two statements are not equivalent. So obviously, this ambiguity can be fixed using parentheses like I just did here in my two versions. But logical statements have their own version of an order of operations that gives you a default order that you should follow. So there are three rules that we're going to use to determine in what order things should be done. And the first rule is negations always come first. Right, so looking at this here, right, we have two possible ways this could be interpreted. We could think of this as the negation of Q and R, or you could do the and first, right? Well, because negations always get done before everything else, this is not the version that we're going to go with, and this one is. You would do the not Q and then evaluate the and. Right, and next, and has precedence over or, which has precedence over conditionals and biconditionals. And the two at the end here are kind of lumped into the same category, just like multiplication and division are at the same level with your arithmetic order of operations. And if that bothers you, it's okay. Just hold on. We'll resolve that when we get to the third rule. All right, so looking at my two statements here, my two examples. Remember, the and takes precedence over or. So looking at this first one here, that means I would do the and first and then the or. So if I wanted to use parentheses to clarify, right, that's how I would do it. Right, now on the next one here, again, the ands and the ors have precedence. Don't forget the negation comes first. So really we should do this first if we're going to do the complete grouping here. Then you would do the or. And finally, that conditional there comes last. All right, so finally, when you have to choose between operators with the same precedence, right, group from right to left. So we'll look at this first example here. Right, I have two conditionals, so I have to decide, do I do the P implies Q first, or do I do the Q implies R first? Well, rule number 3 says we group from right to left. So I'm going to take the right-handmost pair, group those, and then work my way to the left. So that's how I would block out that first example. Looking at the second one, this is how we're going to resolve that ambiguity between conditionals and biconditionals. We're going to go from right to left. So I would group these two first, then of course, right, the negation, and then finally, because it's a conditional or biconditional, and it is the left-handmost one, this conditional would be the last thing that gets done. All right, so now that we've been through all that, I have to give you a fair warning. Practically every programming language has ways to say not, and or, among other things that you can use in programming in an if statement. And the way they order things doesn't always match the way mathematicians order them, the way we've ordered them here. So if you're writing software or you're trying to learn a new programming language, and statements don't seem to be evaluating the way you expect them to, just take a step back, right, and check out the language documentation to see how the specific language you're working with sorts these operators out. All right, so at this point, we've said most of what there is to say about truth tables and statements, both simple and compound ones. So in the next series of lectures, we're going to start talking about mathematical arguments and the different forms that they can take. And this will be a big step forward in our program of trying to distinguish valid arguments from invalid ones.